Welcome to the project demonstration of bank locker security system using iButton. So here we have providing the security systems for the bank locker accessing purpose. So the bank locker is controlled by this DC motor. So for security purpose we have the number of ways. So like fingerprint, means nothing, biometric and RFID and iButton, smart card. So these are the external security providing devices. So in our project we are making use of iButton. So every iButton has a unique code. When we insert that to the microcontroller, so it will getting the power supply from the controller, and it will send the one unique code in serial communication to the microcontroller. So in the microcontroller predefinedly we store that unique code and compare with the received code. Then when it matches, then the system will ask for the again second step of verification. For the purpose, keypad is placed here, and from this keypad we are going to enter the password. So then the system will waiting for the password here. So when the password also accepted, then the system will present the locker opening with help of this DC motor rotation. So your inputs are like iButton and a keypad. So outputs buzzer. So whenever the wrong password entered, then automatically buzzer will be on, and also so-called messages will be displayed on this 16:2 LCD screen as outputs. And when the both are access granted, then the DC motor will be controlled through this transistor board. So here we can observe that. So these two are the transistor boards. So we are using BC547 as a transistor. So as you know that transistor will act as a switch here. So we are going to on the buzzer by on this transistor. We are going to on this motor with help of the same BC547 transistor here. So the whole system operated by this PIC16F877A 40-pin microcontroller. So on this motherboard, so the main inputs interface to this one is like iButton at A0 and LCD at pin number A2 to E3 pins, and buzzer at D1 and D7 for this DC motor, and B0 to B7 for this 4x4 matrix keypad. So on this motherboard we have the three important components. One is the microcontroller, so which will take the inputs and control the outputs. So next, restart switch. To restart the microcontroller, just press and release, then automatically it will restarts. And next, crystal oscillator. We are using 20 megahertz clock frequency, so which will provide the 20 mega clock pulses to the microcontroller per second. So means per second we are getting 20 mega pulses. So the purpose of this pulses is like, so we have a set of instructions inside the microcontroller, means read the input and control the outputs. So these instructions need to be executed per pulse, means per pulse it will execute one instruction, so that we are providing 20 mega pulses per second, so that controller can execute 20 mega instructions per second. So here let us see the demonstration. Before on the kit, keep sure about this, it should be disconnected from the motherboard, and then switch on the power supply to the kit. So then there will see welcome message on the LCD screen, so you can restart that. Right, so please keep iButton. So now we need to insert that over here, not over here. So remember that at this slot. So iButton accepted, and next please enter the password. So in our project presentation purpose, 1 2 3 4 is the password. Access granted. So take your iButton, then we should unplug this, and then thank you. So the motor rotates, means it unlocks. So again it will ask for the next person to control his locker. So now again enter. So if I enter the wrong password, access denied, and I'll get the buzzer out over here. Right. Access granted, and now take your iButton. So the motor controls. Right. So in this manner, using iButton, we are going to provide two-step verification for security purpose. One is iButton, another is the keypad.